Hello everyone, today I am going to discuss UV spectroscopy related Woodward Fieser selection rule for lambda max calculation, conjugated Dienes, trienes, etc. First, we have to remember some values that you are watching on the screen, and that is base value for acyclic or heteroannular dienes, this is 240 nanometer. Base value for homoannular diene, this is 253 nanometer. Alkyl substituent or ring residue, this value 5 nanometer. Exocyclic conjugated double bond 5 nanometer. Double bond extending conjugation, this value 30 nanometer. OR alkoxy group 6 nanometer. CLBr, this is 6 nanometer. And OCOR, this is 0 nanometer. And solvent correction, this value does not change, this is also 0 nanometer. And total, this is lambda max calculation. Lambda max calculated value, this is the total value. First, I discussed what is homoannular diene. Homoannular diene. This is the conjugated double bond present in a same ring, and this is the S-cis configuration. And another example, this is also homoannular diene. This is also homoannular diene, etc. And heteroannular diene. Heteroannular diene, the conjugated double bond are not present in the same ring. That is example, benzene ring, this double bond, or two benzene ring, this double bond are not present in the same ring. This is heteroannular diene. Exocyclic conjugated double bond means this carbon-carbon double bond are protected by a ring. This is exocyclic double bond. This carbon-carbon double bond protected by a ring, and this is exocyclic double bond. This is carbon-carbon double bond protected by a ring. And another example, suppose this ring A, this ring B, and this ring C. This A ring protect, this is exocyclic bond, and C ring is, this is exocyclic bond, but B there is no exocyclic bond. Exocyclic bonds means carbon-carbon double bond protected by the rings. This is exocyclic bond, so A and C having two exocyclic double bond, and this is exocyclic double bond. And next I discuss alkyl substituent or ring residue. This is, suppose example, this first conjugated system required for lambda max calculation, and others part are ring residue. This carbon part, this part are ring residue part. Double bond CH double bond CH2. This is conjugated bond, so this is ring residue. So first we require conjugated system, and others part the ring residue part. And next, double bond extending conjugation system. This is means diene to triene, tetraene. This is, so this is diene, this is homonuclear diene, and form the triene. So this is double bond extending conjugation. So diene to triene or tetraene, etc. This is double bond extending conjugation. First example you are watching on the screen. Example 1, calculate lambda max Calculate lambda max. First, we discuss this is acyclic system. Acyclic system. So base value in acyclic system there is 214 nanometer, and then there is no exocyclic bond, no cyclic system. So there is no exocyclic bond. There is no double bond extending conjugation. So one ring residue, because there is only phase conjugation and another part is residue part. So ring residue or alkyl residue part, this is one part, one. So this is 5 nanometer. So calculate this value is lambda max. Calculate value is 219 nanometer, this value. But remember, lambda max calculate and lambda max observe this value difference plus minus 5. Your question answer, if 219 or 222 near the answer, this is also a right answer, because the calculate value and observed value plus minus 5 difference. Second question, this type, this is the one ring double bond conjugation. So this is homoannular diene. Homoannular diene, we know homoannular diene, the base value equal to 253 nanometer, 253 nanometer, and there is one exocyclic bond. There is one exocyclic bond. This cyclic, this two, this one, the carbon-carbon double bond. So there is exocyclic bond. Exocyclic double bond is 1. So 1 into 5, this is 5 nanometer. And there is residual part. So residue are, this is a conjugated part and another part. This part, and this part. So 3 residue, ring residue 3. So 3 into 5 equal to 15 nanometer. 15 nanometer. There is no double bond extending conjugation. So the value lambda max calculated value is 273 nanometer. This is the answer. Example 3. This is the example. So first, this is heteroannular diene, because no double bond is not present in the same ring. So this is heteroannular diene. Base value, we know heteroannular diene base value equal to 214 nanometer, and there is one exocyclic bond. This is exocyclic bond. This ring, this is exocyclic bond, and exocyclic bond equal to 1. So this is 5 nanometer, and there is no another extra double bond extending conjugation. And residue part, this is phase conjugation. Residue part, this is part, this part, and this part. So this is the phase part. So 3 residue part. So ring residue equal to 3 into 5 equal to 15 nanometer. So this is 234 nanometer. This is lambda max calculated value. So this is the answer. Suppose this is ring A, this is ring B, this is ring C. Ring B having 2 double bond are conjugated and same ring. So this is homoannular diene system. This is homoannular diene system. How we know homoannular diene system base value equal to 253 nanometer, and there is one double bond conjugation, extending conjugation. So double bond extending conjugation 1. So there is 30 nanometer this value, and A having 2 exocyclic double bond. This is exocyclic double bond, and this is also exocyclic double bond. So A having exocyclic double bond 1 into 2, so 2, this is 2 double bond, 2 into 5, so 10 nanometer. And C and B there is no exocyclic double bond, 0 nanometer. Having C, there is exocyclic double bond, C, this ring having 1 exocyclic double bond, so C having 1, so this is 5 nanometer. And ring residue means we know this is conjugated, fresh conjugated part, so this is ring residue part, this is part, this part, this part, this part, so total 1 2 3 4 5. So ring residue equal to 5 into 5 equal to 25 nanometer. So total calculated lambda max calculated equal to, this is 253, this is 30, this is 10, 0, 5, 25, so 30, 10, 40, 30, 70, this is 7, 3, 2, 3 nanometer, so 3, 2, 3 nanometer. This is the answer. So next day I will discuss alpha beta unsaturated carbonyl compound, the lambda max calculation. So please stay with me and like, share, subscribe. Thank you.